If I'm at angle 2, angle 2 and 10.
What are they?
Angle 2 and 10, what's the angle correspondence between those two? Corresponding, very good, Joe, very good. Those two have to be corresponding angles. Are they congruent or supplementary? Very good. Okay. Angle 3 and what would be alternate interior? Angle 3 and what has to be alternate interior? Can I jump? It has to be 7. Very good. It has to be 7. No, because this is on the inside of these two lines. It's on the outside of those two.
What did you say for
7. Of course. 9 and 8, these guys have to be same side inside, same side interior, consecutive interior, depends on how you write it out.
Wait, what is the consecutive interior?
Consecutive interior or same side interior means the same thing.
Same side interior.
What angle could you show us congruent to 11 to prove that A and B are parallel? What would have to be congruent to 11 to make A and B parallel? What would have to be congruent to 11 to prove A and B are parallel? It has to be 9. Has to be 9. Has to be 9. It's always nice when you're kind. Oh, speaking of being kind, hey, every time you leave more trash on my floor, I'm doing push-ups. I'm a coach. Yeah. Yeah, we're on the same wavelength because you've left water bottles in here all week. You left that wrapper on the floor the other day. You've left pieces of scrap paper lying around. So yeah, every time I'm gonna watch every day, and I'm gonna get a hold of Tito and let him know it's good to read. All right, cool. It's great. Relationship between 6 and 11. If you want the relationship between 6 and 11 to show that C and D are parallel, 6 and 11 have to be either supplementary or correlated. Congruent, what would they have to be? Supplementary. Could they be congruent? If they're congruent, what would they have to equal? Very good. If angle 6 is 50, what's 11? No, it's 1244. I know it's old. I get it. I know it. I'm sorry. If angle 2 is 70, what does angle 6 have to be? 70. If angle 1 is 130, angle 5 has to be 130. If angle 7 is 110, angle 10 has to be 70. 110, they have the interiors, they have that. You would just and then if 4 is 45, 12 has to be 45. So you're asking about which one? Sorry, I can't remember. 6. If 6 is 50, 11 has to be 130. Working through the solving for x's and y's within triangles. Also, you've got some angle stuff to worry about. In number 11, this is one style that we have done over and over and over again, where you've got an exterior angle. An exterior angle is always equal to the sum of the two angles it does not touch. So that means that x plus 20 has to equal 150. It gives you 2x is 130, it's 65, and y is 30. Okay, really, really easy stuff. What does x have to equal in 12? 40. I'm sorry, I couldn't hear you. What? Yep, you can do that too. But the reason that I didn't do that way is because if I go x plus 20 plus 30 is 180. Oh, it's triangle. Because as soon as you move the 30 over, you get 150, and that's where that exterior angle comes from. It's just a shortcut. Your way is fine. Do it. Go ahead. I just did I did it with just basically half a step shorter. If you did it that way, there's nothing wrong with it. You got the right answer. You will always get the right answer if you math correctly, but you will, it's fine to do it that way too. Okay? In 13, x and y, well, y has to equal the sum of those two. 39 and 49, I believe, is 88. So if that's 88, the other side has to be 92. You have a bit of a mess, but you've got a bunch of vertical angles to work your way through, so it's pretty quick. In 15, oops. When a line is perpendicular to two other lines, the two other lines will always be parallel. This is an example of basically like the line paper you have in your notebooks. You've got that red line going all the way down, it's the tab line, if you will, and all the blue ones are all the horizontals. So as soon as you are perpendicular to two lines, those lines have to become parallel, which means that you can solve for A and B in the next set of transversals. Well, when you get to the transversals, remember the one trick that I showed you guys was if you follow through your tick marks, if they both have a tick mark, they will always be congruent. If they both don't have a tick mark, they will be congruent. If one has a tick mark and one does not have a tick mark, they are going to be supplementary. All right, let's go. So that means these two are going to be supplementary. So you get 5a minus 43, 7a minus 17, 180. You get 20. To get to the next one. What's that? What do you mean? For the next one? They have to be equal. So you have 8b equals 11b minus 30. So 30 is 3b. So that's 10. Oh yeah, real quick. The one I just did a second ago for finding A, you see how you get A equals 20? Yeah. During second hour, someone brought up, they checked their answers to see what had happened, and they're like, well, Mr. Murphy, the angle on the bottom of 7 is so much bigger than the angle on the top, but yet the angle on the top looks like it's bigger than the angle on the bottom. I didn't know if I was right. I said, stop whining. And it's not drawn to scale. I didn't say so many words, but kind of. Remember, it's not drawn to scale. It's kind of the idea. I apologize if I offended you, bless you, in such a way that I made fun of something. But I didn't. Ish. You'll get over it. But yeah, remember, it's not always drawn to scale. Hence why my sailboat of death wasn't drawn to scale as the guy fell off and got decapitated by the sail. He couldn't see anymore, though. It was a detached retina problem there. My ears are clogged up. What's that? Oh, see if you can fall. If you will a sail decapitate you? If it's made of razor blades.
Very interesting sale.
How did you know that the variables would be equal to each other?
What's that?
How did you know that the variables were?
Oh, guys, good question, good question. The reason why I know that these two guys are equal to each other is because the lines are parallel. So I picked the spot, I worked through, there I go vertical, alternate interior vertical.
Okay, so wait.
No.
Great conversation.
Yeah.
Vocabulary, vocabulary. So when we got back to vocabulary, and when you get into chapter 4 was that death chapter for most of you guys. How much you loved it. No. Here's the thing. When you're dealing with chapter 4, you're dealing with the proof stuff. And when we did the proof stuff before, he's doing. We did all that proof stuff in chapter 4. It was always predicated upon the fact of knowing other definitions and stuff. But in order to be able to do the proof stuff, you had to know how to set up the proofs. You had to know what you were looking for in the long run. Now, number one, this first question here is talking about, again, the idea of an exterior angle. So the outside angle has to equal the sum of the two it doesn't touch. So that one's super easy to set up. So what do we get here? We have 6x the exterior angle of a triangle has to equal the sum of the two it does not touch. So we get 6x minus 7 is 103 plus x. X in this case was 8. Okay. Like we said, it's kind of difficult to do proofs, but yet we can still figure out how would you say that they are congruent. I don't think John's a crackhead, but that's not the nicest thing to say of a friend of yours. Oh yeah, you're right. I wouldn't want to stoop that to your level. Wait, no. Yeah, I wouldn't. You don't want to put your feet down. Anyway, good save, John. Now, when you're going through the diagrams, a couple of things that we always did is that we were able to mark specific parts. When you mark certain things in diagrams that you're allowed to do, for example, in number 2, what can I mark? Vertical angles, very good. I can always mark vertical angles, okay? Now, is there enough information in between those two triangles to say that they're congruent? Yeah. Via what? Oh. Angle, angle, side. Angle, angle, side. Remember. Angle, angle, side. The next one, what do you have to mark? Reflexive, very good. The reflexive side. Reflexive is a shared side, which gives you side, side, side. Number 4, what do you mark? Vertical angles again. Hey, doesn't this seem to show up a lot whenever you see two triangles that look like a bow tie?
Yeah.
Boy, don't you think your teacher might have mentioned that at some point in time?
Isn't that angle side angle?
Joe, it is angle side angle. I know. Shut the front door. You honestly think I was going to drop the F-bomb? Come on now. I've only done that once.
Angle side.
Reflects it, right?
Yes.
Joe, there's no ass in math.
Right.
Hypotenuse leg. Very good. This is a hypotenuse leg. Hypotenuse leg is when you've got a right triangle. In this case, we know we have right triangles because of the right angles. The hypotenuse. The hypotenuse happens to be across from the right angles. And it works. Right? Do you have to always use hypotenuse leg if you've got a right triangle? No. You can get side, angle, side. It's not a big deal. Okay. In 6, is there anything you can do? Nope. Which means you say, go to number 7. In 7, what do you have to mark? Vertical angles, which gives you side, angle, side again. Very good. And then lastly, you've got the reflexive again. Side, side, side. Now, do me a favor. Flip to the very back page of the review real quick. And I want to talk to you guys about how the proofs are going to be written out.
You like that?
Yep.
It's not too bad. It took me like 5 minutes. Yeah, I'm sorry. No, I didn't get it.
All right, ladies and gentlemen. So, as I've said this, I started kind of talking a little bit about it the past couple of days. When we get into the proof portion of the final, the proof portion is just 7 questions. 7 out of the 45 questions deal with proof. So that's basically 15% of your grade. So as you start going through this, excuse me, as you start going through all of it, it's a matter of you're going to be given this basically the same style setup, where you have this reason bank for each, the top algebra one, and then you have the bottom one with the geometry. You have 2 different reason banks. So in this algebra one, you only have 3 steps, even though you're given 5 parts, which means, are you going to use all of them? No. Could you use one twice if you had to? You could. All right, it's one of those things. So as you're going through here, you have to just decipher what happened. What went from one step to the next? So if I'm looking at the first part, 3 times the quantity x plus 1 is 24. To go to 3x plus 3, you had to distribute. Exactly. So which one of these possible here says distribute?
I don't know, maybe.
E? You say E? Z?
Maybe B.
Was it B? Alright. So, from there, going from 3, oh man. Going from 3x plus 3 is 24 to 3x equals 21, what happened? A? A?
Yeah, I just heard there was B. Are you supposed to write the letter?
You just write it in because whoa, guys, listen. What's happening here is this part, I believe, is going to be on the multiple choice. So you'll have a bubble. And or is this on the other part? I forget where it's going to wind up. If it's in the multiple choice, if let's say this is question number 31, you would bubble in B. 32, you bubble in A, and so on.
That's
All right? And then lastly, to go from 3x equals 21 to x equaling 7, the division.
VAC.
Same thing goes for the algebra one, or the geometry one. When you have the geometry one, remember the rule, my suggestion to you guys over and over and over again was always to mark your diagrams. So as you start with your givens, if you're given that A and C are congruent, what are you going to do? What are you going to do to the diagram? You're going to mark it. Those thingies, yes. Next, you have x as the midpoint. If x is the midpoint of AC, that means you get two congruent segments. So AX and XC have to be the same.
And then you got some verticals.
And then you got some verticals. Well, you have some, but I'll go with it. Now, if I'm just looking at the diagram without doing anything, do I have two triangles that are congruent?
Yes.
How?
Because it's C.
Ah! How do we prove for triangles are congruent?
Oh.
Angle, side, angle.
And then they got the C.
So, going through my steps now, obviously the first part is given. The second part says angle AXB is congruent to angle CXD. Well, let's find it in our diagram and see what we marked. AXB, CXD. Oh, we marked them because they were vertical. I go to the next one. AX is congruent to CX because when I marked AX congruent to CX because they were a definition of a midpoint.
Yeah. AC.
I now have triangles congruent because I've already written that down why they were congruent on my sheet because of angle side angle, which is D. And now that since you've had triangles that are congruent, therefore all of the corresponding parts of congruent triangles are congruent. So that last bit is E. Okay? Guys, this should be the easiest part of the entire test. It really should, because it's the idea of following through the flow of the problems and just filling in the blanks. Okay? Five. Chapter 5, you had a lot of the weird vocabulary. Oh, sorry, thank you, sorry. The last bit of 4, you have isosceles and equilateral triangles. Isosceles and equilateral triangles. When you have equilateral triangles, it means you have all the sides are the same, and you're going to have all the angles being the same. If all the angles are the same, that means they all have to equal how much? 60. So in this first one, you know that for y has to be 60, x plus 20 has to equal 60. So y is 15, and x is 40. It's equilateral. Equilateral triangles have all three angles that are congruent. Equilateral means that they are going to be what we call equiangular. In number 10, you've got two sets of isosceles triangles. So when you have two sets of isosceles triangles, that means you've got the legs always point towards the base angles that are congruent. So in this case here, these have to be equal. So this is 59. 59 and 59 subtracted from 180 leaves me an angle for x, which is 62. And then I use that value of 62 vertically to get to the other isosceles. And lo and behold, if you take 62 degrees out, that leaves you 59 and 59 for the other two base angles. And it is completely, perfectly fine that you have two sets of triangles with congruent angles. It doesn't necessarily mean that you have congruent triangles. it is possible that you wind up with what are called similar figures, because, and we'll talk about that in chapter 7 about specific ratios and things like that. Same thing goes down then when you get to 11, you've got an isosceles triangle. You know that you have isosceles because you've got they're pointing at the base angles that are congruent. Very good. Gives you base angles of 65, add together you get 130, subtract from 180, and look what it says. Number 12, you've got an equiangular triangle. If it's equiangular, it has to be equilateral, which means all the sides have to be the same. If they give you one side that is 24, therefore all the sides have to equal 24. So 2x equals 24. X is 12. 3y is 24. Y is 8. I will remind you that it's not a bad idea that you remember that the vocabulary in chapter 5 was probably the weirdest vocabulary. It's the ones you never really saw all that much. Make sure you revisit the terms that are in 5, especially the circumcenter, incenter, centroid, orthocenter thing. And then it's just a matter of solving for x in the first few. First one, you have a mid segment. RS has to be a mid segment because it connects the midpoints of a triangle. Mid segments are parallel to the side it doesn't touch. They're equal to half the side it doesn't touch. Therefore, x is going to equal half of 27. So depending upon what the answer is, it could be 27 over 2 or 13.5. The second one makes you have to think. The second one is making you think because you've got mid segments in a triangle. Remember, each mid segment is equal to half the side it doesn't touch. So if the perimeter going all the way around is 96, that means that the perimeter going around this has to be half of it. So 4x and 1, 2x, 3x and 2. Oops. Half of 96 is 48. Okay. And the idea is if that segment AC was 8, bless you, that means that each chunk of it would be 4. So what you're doing is you're just adding up half the sides to get to that. 2x, 3x, and 4x gives us 9. And it's really quick. You get 5. Okay. You get x is going to equal 5 in this one. Okay. Excuse me. Altitudes and medians. Montana and I were talking about this earlier. A lot of times when you're looking at problems in math, it's one of those things where you either know the definition well, or you can kind of fudge your way through it. I do too. Now, in this case, it said that AD was an altitude. Altitudes are always going to be from a segment from a vertex to a side opposite that is perpendicular. Now, if you're looking at it, And you know that this is some degree value. If this is going straight to there, what could you probably get away with doing? Making it equal to 90. Okay. You get some quick math. Same deal with BE. It said that BE is what we call a median. Medians are always going to be the segments drawn from a vertex to a midpoint. Well, if it's a midpoint, that means that both sections AE and EC have to be equal to each other. So you set them equal to each other. Once again, if you're just looking at the diagram, not sure what to do, you're looking at that, obviously segments don't equal 180, so that means segments have to equal how much? They're going to either equal double one, or they're going to equal each other. You just set it through that way. Hey, lo and behold, we mapped it correctly because we got 15 for x twice, which means we did it right.
Yeah.
Oh, I could have done it wrong twice, correct? 2 wrongs don't make it right, but 3 lefts do.
Yeah.
No, 3 lefts do. You don't get it, Libby? You don't get it, dude. Stand up. Stand up.
Left, then you go left, and then you go right.
There's no way to. How do we decipher smallest to largest via angles and sides? Draw it out. Yep, doodle it. So if I'm dealing with side lengths, I want to put them in order of smallest angles from smallest to largest. Guys, if AB is 20, BC is 12, and CA is 10, which one of those angles has to be the largest? C would have to be the largest. Which one has to be the smallest? B. So I think this said put the angles in order from smallest to largest. So it would be angle B. Then the next smallest angle would have been A. And then the next one would have been C. And then same deal if you're given angle measurements. If you're given angle measurements, we have 100, 20, and 60. Which side length has to be the smallest? Smallest would have to be at AC. The next smallest would have to be at AB, and then therefore the largest would be BC. Okay. It's just a matter of going. Remember, the smallest angle will have the shortest side length across from it. The largest angle, the largest in the middle. Okay. Next to, again, if you're on an angle bisector, that means you have to be equidistant and perpendicular to the sides. Well, this works out to be one of those types of problems that if you just kind of look at it correctly, what do you have to do? You can probably guess what to do. They have to be equal in order to make it work. Is he 12? No, I'm sorry. Oh yeah.
You're right.
It is, folks.
I looked at the 7 before they had the accident. Wait, no, that's 16. Murphy's right
Yeah.
Okay. Same deal. On 10, you are on the perpendicular bisector. When you're on a perpendicular bisector, that means that you actually create an isosceles triangle. So those two legs have to be the same. So 4x and 6 has to equal 6x minus 3. You get 9 halves, or 4.5. And the last ones are the weird ones about dealing with what we call that centroid. When you're dealing with the centroid, remember we had certain scenarios, depending upon what you are given.